We have finally got it, the 14-inch MacBook Pro with the M1 Max processor, so we can compare it to the 16-inch and answer the biggest question once and for all: how much performance do you lose with the smaller chassis, the smaller fans, the smaller heat sinks, and without that high power mode on the 16-inch MacBook Pro? And I am not gonna go easy on these machines. Now, as a bonus, I have both these machines at 100% battery life. So as we go through these tests, I'll be giving you guys updates on how the battery life is doing and how much longer the 16-inch will last with its larger battery compared to the 14-inch, which also will likely have to spin up its fans more so, draining more power. Now, right now, both of the fans are off and the idle temps surprisingly are exactly the same. They keep bouncing between 1 or 2 degrees of each other, so there's no difference there just yet. And of course, we're gonna do a wide variety of tests, stressing both the CPU, but mostly focusing on GPU performance, because that is what the 32-core M1 Max offers over the M1 Pro. Let's go ahead and unplug both these bad boys and begin. The first thing I'm gonna do is run GeekBench 5 CPU test to see if we have any differences, but I don't expect any. And here you go, the results are practically identical and the fans stayed off on both machines the whole time. And now let's run the compute test, which does a bunch of various metal accelerated tasks. And some of you may know that GeekBench 5 doesn't use the full GPU performance, but I wanted to run it to see what kind of peak wattage we get and if we see any differences between the 16-inch with the high power mode, allowing a bit more power or faster power ramping for graphics. And here you go, the test is done, and this is interesting. The 14-inch actually hit a higher peak of 36 watts compared to 33 watts. And here are the results. We have 69,000 for the 16-inch, which is actually the highest we've gotten, and 67,000 for the 14-inch, just slightly lower performance, but that's only in GeekBench 5. I realize the backgrounds are gonna be annoying that they're the same, so let's swap that background over and let's jump into the next test that's gonna push these machines, and that is Cinebench. And the reason I'm running this is to see if that high power mode affects the CPU performance at all between the 14-inch and the 16-inch, or if it's only the GPU. We're almost at the end of the run, and surprisingly, the CPU frequencies are basically identical, at least so far in this 100% load. We have the results from the first run, and the 14-inch is actually about 50 points higher than the 16-inch. I'm gonna go ahead and run a few more tests just to allow them to heat up more so and see if we slowly start throttling on the 14-inch and the 16-inch can still run faster with that mode. Now we're on our 5th run, and so far everything's been very consistent. The only difference is that the 16-inch's fans are running slightly above idle. They were pretty much idle almost the whole time until this 5th run, whereas the 14-inch, as you guys see, they're about 2/3 of the way up, about 4,300 RPM, and this one I can hear it, but it's still very quiet. And for the final results, the 14-inch is still about 50 points ahead of the 16-inch, so no, the high power mode does not affect CPU performance at all. So let's close this down and jump into GPU tests. We're gonna use 3D Mark to max out the graphics, and I'm gonna switch back to automatic power mode when I do this first run, and then afterwards we'll switch it to high power mode and see if there's a difference. All right guys, wow, we're seeing stuff already. We have our results here, and even in the automatic mode, the 16-inch still gave us 121.4 frames per second compared to the 14-inch, which gave us 108.8. That is a difference of 11.5% in favor of the 16-inch. Now, I'm gonna go ahead and run this one more time in high power mode. That way we can see if there's a difference. I know it's gonna be close, and I'll run it again on the 14-inch just for the sake of our battery life comparison. All right, very interesting. Looks like our 16-inch went down slightly in performance with high power mode, and the 14-inch did slightly better this time, but the difference is still roughly 10%. Now, there's two things that I'm very curious about. First, does the GPU run slower as far as frequency or wattage with the 14-inch? And second, could it be that for the 14-inch, if you want the full performance, you actually have to plug it in, which is unlike any other Mac ever? Let's go ahead and run this, and we're gonna watch the wattage and the frequency. Look at that, our 16-inch is running at 1,249 megahertz compared to about 1,130 on the 14-inch. And look at the wattage there. The 16-inch is getting 43.3 watts compared to only 35.39 watts on the 14-inch. This proves that Apple is intentionally throttling the 14-inch even if it's not hot. Now, I haven't seen anybody show these findings yet online. We had to wait for our 14-inch to come in the mail, but I want to run this one more time plugged in. So I'm plugging both in just so we are doing this fairly. And let's see if that changes on the 14-inch, if it can beat that peak wattage now that it has a power source. And look at that, the frequency is still limited to just over 1100 megahertz, and the wattage did not change. It went slightly higher, but insignificantly compared to the full 1.3 gigahertz with the 16-inch model. So what is gonna happen once we're doing an extended workload when the systems heat up? Is this thing gonna be limited even more? Let's go ahead and find out with our extreme stress test, which is gonna run for about 20 minutes. Now, I know this is a gaming graphics benchmark, but it does show us the full performance of the GPUs compared to other tasks. We will do some video editing and other tests here in just a bit. And we're on our second loop now, and this is crazy. The fans are actually spinning louder and the system is hotter on the 16-inch. Now, that is because right now we are averaging 42 watts of use on the graphics here, the 32-core M1 Max, compared to just averaging 23 watts on the 14-inch. And because of that, it's actually running a little bit quieter and slightly hotter on the CPU, but the fans are kicking up now. We'll give it a few more runs, but the power draw difference is crazy. Now, I understand why Apple might want to limit the 32-core M1 Max on the 14-inch. Obviously, we have, thermals, we have those smaller fans I showed you, but we also have that smaller battery as well. And with the smaller battery, they just might want to save power. They might want to give you better battery life. And of course, in our first run, we saw that we had a difference of about 11.5% performance, but it used about 22% less power. So that's a pretty good trade-off for performance while saving a good amount of battery life. Now, here's something else that nobody has told you yet on the internet. Actually, two tidbits. First off, the fans in the 14-inch model, they actually spin faster. We have a maximum of 6,241 RPM compared to 5,776 on the right side fans. And then on the left side, the 14-inch fans also run about 400 RPM faster. And the second thing is that even if the fans are running slower on the 16-inch than the 14-inch, they actually are louder on the 16-inch just because of how much air volume is going through that cooler, which I also did not expect. Now, it's been about 10 minutes. Everything gets kind of stabilized, but earlier on, the fans were running much higher on the 16-inch because it got too hot and it was trying to cool it down, and then it was just so much louder than the 14-inch. And then now, after everything's settled, it's actually running cooler on the 16-inch and still slightly louder, but the fans have a lot more headroom if we throw in extra CPU usage. Now, with that said, the 14-inch is already throttling the GPU even more than before. We saw it ran at 1100 instead of 1300 megahertz, but constantly throughout this stress test, we are literally running between 950 to 1000 megahertz compared to the full performance not throttled on the 16-inch. So that is already a little bit disappointing. Now, what I want to do is I'm going to go manually hit max on the fans just to see if we can get full performance by maxing out those fans, because we have a little bit of headroom here, and we see that Apple is choosing to throttle the 32 cores instead of running the fans at full speed just to keep it cool. And it looks like nope, even with the fans maxed out at 6,200 RPMs, we're still not getting any more performance, still fluctuating in that range. Now, what is gonna happen if we introduce a CPU load as well, which happens in some really intensive tasks like editing 8K video and other tasks where you're pushing both, not just the graphics? We're gonna see in just a bit. Now, I accidentally closed the reading mark incorrect way. I wanna see the scores, so I'm letting it run a few more times before that, but we do see that the 16-inch under extended load, it was using about 60% more power for the graphics to get better performance. And under the on-screen extended stress test, we saw a difference of over 16%. And now let's start that Cinebench, and I think this is gonna get ugly. All right, guys, look at that. So now the GPU is running at 700 megahertz compared to about 1,000 or 1,100 megahertz on the 16-inch. But the crazy thing is that under this load, the 16-inch is being throttled much more than before, while Apple is still not choosing to max out the fans on this thing, but slow down the graphics. So let's go ahead and jump into some other more real world tests than maxing both systems out and testing out their cooling. Obviously, we know if you're gaming, you definitely are gonna get better performance on the 16-inch. And while we do that, let's go ahead and take a look at the battery life throughout all this crazy testing, pushing these machines. Our 16-inch is still at 33% after hours of testing. And the 14-inch, go ahead and guess down below what it's at. Let's take a look. And it is at 16%. So we still have maybe about double the battery life on the 16-inch, but it's not as big of a difference as I expected. And of course, we know now that is because Apple is throttling the graphics on the 14-inch to save battery life. And now let's test out Blender. I have Party Tug opened up right here, which uses the graphics to render. And let's see if a quick render like this will make a difference as far as everything else that we found so far. I do have both machines plugged in because the 14-inch was close to being out of battery. And look at that, we have 6.03 seconds compared to 6.02. Of course, this is only a 6-second render, but the graphics were maxed out and the performance was the same. Let's make this a little more difficult. I'm gonna add on a lot more effects. And this time the CPU was used more so, but we have almost identical scores, 24 seconds for the 14-inch compared to 24.33 for the 16-inch. So why in the world are we now getting the same performance? Well, if we take a closer look, it looks like for Blender, neither machines are going above 24, 25 watts. So the artificial limitation that we saw that Apple put on the 14-inch earlier, it's not being exceeded anyways. And that might be because Blender doesn't use metal yet. Apple is working with them for that. So for the graphics related tasks, it's using the older OpenGL. And now let's get into some video editing that's gonna use the encoders, the CPU, and the GPU. And before I jump into this project that's over 30 minutes long, I wanna say, if you guys enjoy this content, please hit that subscribe button down below. We're trying to reach our goal of 1 million subscribers before the end of the year. That would be amazing if we had your support. And if you're a fan, check out our merch down below. We have this shirt in a lot of different colors. It's very subtle and looks great in black. We have hoodies and a bunch of other stuff. We would greatly appreciate it. Now, let's go ahead and play back. And this project here, it should play back great on both these machines. This is our comparison against the Razer Blade with the RTX 3080, and with links this long and different animations, graphs, effects, it definitely takes a hit on our iMac that has 16 gigs of RAM and the M1. So what I'm gonna do is go ahead and export this. I'm using HEVC, that way we're not limited by the encoders and we give the graphics the maximum amount of work that it can. And we are off with the graphics cards being completely maxed out on both. So we're a little over halfway done, and it's very interesting to see that for this test, the graphics card will max out and then it will drop down a little bit and kind of take a little bit of break. It's probably done enough work and we might actually be limited by encoders still, and then it'll kick back up, and then the CPU is only running at roughly 20% or so. And because of that, it's incredible to see how cool and quiet these machines run. The CPU is not maxed out, the GPU is not maxed out. So Apple did a crazy job with those insane decoders and encoders, which makes us run so efficiently. And now we're about 70% or so through, And basically the only difference I'm seeing is that the fans are on the 16-inch. They're literally at the slowest speed possible, and we're at 68 degrees Celsius on the CPU, 64 on the GPU, compared to maybe about 25% of the weight on the 14-inch, and that's running hotter, 79% CPU, 77 GPU. And we are done, and that is just incredible how a 4K project with graphics and effects and different stuff that's graded, that's 30 minutes and 46 seconds long, finished in 8 minutes and 50 seconds on one machine, 8:51 on the other, literally 1 second of a difference, while being so cool and quiet. That is just insane. Just that performance is more than enough to do this. So we're gonna have to make it even more difficult, and that just shows us that, hey, if you're video editing and you're working on stuff that the encoders and decoders can handle, we're not seeing that much of a difference graphics-wise with normal projects that regular people do. But what happens if we make it a little tougher? Now I'm exporting a 5-minute ProRes RAW 4K project, and this one is pretty much pinning the GPUs, and because of that, we're starting to see some of the difference in graphics performance that we found earlier. Wow, that was incredibly quick for a 5-minute ProRes RAW project. Of course, they have encoders in these systems for ProRes, and the result is 46 seconds for the 16-inch and 49 seconds for the 14-inch. That's a difference of about 7%. So if you had a longer project, not 5 minutes, or you had more effects, that would be, longer times savings. And of course, the systems did not heat up in this test because of just how fast it was able to do that. So now let's go ahead and open up an 8K ProRes RAW project. Now here I have stacks of 4K and an 8K timeline, creating pretty much 8K ProRes RAW that has to be debayered, decoded, and then obviously have effects and LUTs on there for encoding. Let's go ahead and play both of these back, and this is just crazy performance from a laptop right here. It looks like we're using about 75% of the graphics on the 16-inch, 73 on the 14-inch, we're up 73 over here as well. So even with 8K ProRes RAW, stacks of it in an 8K timeline, real time debayering this, adding the color grading, we're not maxing out either graphics. So because of that, we're still probably not seeing any difference because this is able to give us the full performance, and that is just mind blowing. Now this is editing. Of course, maybe if you added a little more effects, maybe I can make it even more different, but we're making it as difficult as possible. Let's go ahead and export this 8K 5-minute project, and let's see the difference. And bam, you can see that the graphics are being pinned right now. The systems are starting to heat up, and the fans are gonna have to kick in, and we might see some throttling on the 14-inch. The fans on the 14-inch are pinned to the max, whereas the 16-inch is only about halfway, and the export is done, and we do see a difference. The 16-inch took 2 minutes and 54 seconds compared to 3 minutes and 26 seconds for the 14-inch. So that's a difference of over 18%, and that is because the graphics were pinned, and in that case, when I looked at how much power they were using, the 16-inch was using pretty much double the power of the 14-inch, so it can hit higher clock frequency. So it's a lot more power there for not a huge difference in performance, but if you do want the best performance, that is bigger than we even saw in our first short-term gaming test. And I think even the throttling gaming test was about 16% difference or so. Now, this does have encoders, and that's why it was so fast for 8K ProRes RAW, 5 minutes being so quick to export. Now let's do a test where it's gonna push more of the CPU as well as the GPU. We'll do one last test here. This is 8K Canon RAW in an 8K timeline that is graded, and I have to play it back in better performance mode in order to even play it, or else it is just choppy. So let's export this 5-minute project. And as you see, both our CPU and the GPU are being hammered right now. Wow, 103 degrees Celsius on the CPU on the 16-inch, graphics at 91 while the fans are ramping up. 105 Celsius, that's crazy. Even the 16-inch can get that hot with the craziest tests. And while our 14-inch is getting hot, it's not getting that hot because it is being power throttled for the graphics. All right, guys, we have our results. The 16-inch took 7 minutes and 42 seconds to export this 5-minute project, maxing out the CPU and GPU, whereas the 14-inch M1 Max took 10 minutes and 4 seconds. That is 31% faster for the 16-inch model. So that is actually the biggest difference we have seen. Now I also went ahead and turned off the high power mode, set it to automatic, and exported, and it didn't seem to make any difference at all. The export actually finished faster by just a few seconds, about 6 seconds faster than before, which is crazy. And the crazy thing is, the fans were only up halfway, even though the CPU was at 103 degrees Celsius and the graphics at 91. At that same time, exporting again on the 14-inch, the results were the same, and just the fan is at full blast trying to keep everything hot. Whereas a 16-inch, I wonder why it's not ramping up more so. Maybe it knows that there's no throttling going on anyways, so it doesn't have to run the fans at full blast in order to do that. I'm not really sure. So I'm not really sure what the high power mode really is for. Maybe I'll try the ProRes version one more time, since MKBHD said he did get a difference. All right, guys, so I ran that test. I saw no difference. I unplugged the machine. I ran the test again. I saw no difference with the high power mode versus the automatic mode. And then I went back to this crazy 8K test that just punishes the machine, and I had it unplugged this time, not plugged in with automatic mode, unplugged on battery. I ran it, and then I finally saw a difference. And instead of being fast, taking 7 minutes and 40 seconds, it took just over 10 minutes. And so that pretty much matches up with the performance of the 14-inch plugged in. So basically, the only time that high power mode matters is 1, only if you're on battery power, and 2, only if your application maxes out the CPU and maxes out the GPU, just like what MKBHD saw in his red to ProRes test. But if your graphics card is maxed out, but the CPU is at 50 or 60%, and you're on battery power, it still doesn't make any sort of a difference. Now, if I had a 16-inch, I would still enable it to make sure I'm getting full performance if I'm on battery, just like Macs have done for years. So technically now we know that this is the only machine that will limit you if you only get the highest spec and you max everything out and you're on battery. You might see a difference unless you toggle that mode, which I probably would toggle it because most of the time it doesn't make a difference anyways. So there you guys go. What is the final verdict on the M1 Max between the 14-inch and the 16-inch? Well, we believed, or we thought, that we're gonna get worse battery life in the 14-inch, and we did. We saw that difference at the start, but it wasn't as bad as I expected, and that is thanks to Apple downclocking and undervolting the graphics in this machine to help with that battery life. Now, I also wasn't expecting as big of a difference in performance. So in the smallest cases, if you're just running the graphics card and we're not thermally limited by the CPU, you're getting around 11% difference. But in longer term tests, let's say if you're gaming or doing something else, it goes up to about 16% difference in performance. And then if you're just punishing the machine, you can see up to 36% performance difference between a 14-inch and a 16-inch. And in that case, if you need the best graphics performance, we now know that you absolutely should go with the 16-inch model, because that gives you between 11 to 36% better performance, and of course better battery life if you go with this larger size for $200 more. Now, with that said, if you are somebody that really wants the 14-inch for the compact size, this is the first time ever you can match up spec for spec between a large one and a small MacBook Pro. Well, if you don't push your machine that much, or you do short bursts of high intense workloads, or you're doing video editing with different encoders, or you're doing Blender, you could definitely get away with the 14-inch. It might be a little bit worse performance, or about the same if you're not pushing it hard. So there you guys go. We found multiple different things that I have not seen anybody else mention or find, and this is our main verdict for these machines with an M1 Max. Now, we also are going to be covering 32 gigs compared to 64 gigs. So if you're interested in that video, make sure you click that circle above to subscribe and to help us reach our goal of 1 million subscribers. Check out one of those great videos right over there. This has been Max, and I will see you in the next video.